Okay, good afternoon once more again. This is our third lecture on web development with content management systems. Today we are going to talk a lot more about concept. So we will start with a web computing concept. What is web computing? Well, several people have several different definitions for what web computing is all about. But in short, web computing is just a special kind of distributed computing that involves internet-based collaboration of several remotely distributed and remotely located computers. Now, components in a web computing environment are not fixed. I mean, they don't have fixed hardware configuration, and they are not confined in a single local area network environment. The aim of web computing is to make functionalities easily migrated between one platform or one computing infrastructure to another. It usually requires a runtime environment, broadband connection, and flexible software structures. And I can't talk about web computing without mentioning cloud computing, because cloud computing is one big enabler of web computing these days. So I'll talk about cloud computing, but before that, let me talk first about distributed computing, which is, in other words, the predecessor or the brainchild of cloud computing. Well, what is distributed computing? Distributed computing is simply a system that solves computational problems. So distributed computing is nothing other than an approach wherein a single problem is divided into many different tasks, and each one of these tasks is solved by one or more computers that are interconnected, but each one of them work autonomously. So Berkeley University have a very good project, which is a distributed computing project, and it's an excellent example of this. You can check BIOS, servers, storage, applications, and services. These services, these networks, these servers, and these storage devices can be rapidly provisioned and released with minimal management effort of the service provider. So you can log in most of the time, create each one of these services yourself automatically, or provision each one of these services automatically with few clicks. The service provider will not have to talk to you, and you will have no direct interaction with the service provider. Now, with this definition, the cloud model composed of 5 essential characteristics, 3 service models, and 4 delivery models. So we will talk a little bit more about this, each one of these models. You can see the source down there is a PDF that has the complete definition according to NIST, and you can look at it at any time. So the essential characteristics: 1 is on-demand self-service. So a consumer can unilaterally provision computing capabilities such as server time and network storage as needed automatically without requiring human interaction with each service provider. So you can get to the service provider's website today, and you can demand these services by clicking and going through on-screen instructions and provision them without having to talk to the service provider. Broad network access. Cloud computing is impossible without the network access. So you have broad network access. Capabilities are available over the network and access through standard mechanisms that promote use and of thin and thick clients. These are mobile devices, tablets, laptops, workstations, and all this. So you can access cloud services on any one of these devices automatically as thin clients or thick clients. Resource pooling. The provider's computing resources are pooled to serve multiple consumers using a multi-tenant model. So like you have Amazon Cloud Services or Microsoft Azure Cloud Services or Rackspace Cloud Services. These services are available. They have a whole bunch of devices in their data centers, and you can pull them in and use them as and when you want. Rapid elasticity. This is the capability for the devices or the resources to be elastically provisioned. So you can start with one server and end up with 3, 4, 5, 6, or 7 servers as and when you need them. Essential characteristics, again, measured service. Cloud services are usually measured. Not usually, they are measured. And today with Amazon Cloud Services or Microsoft Azure or Rackspace, or pretty much all of them, they are measured by the hour. You pay for the use of the services on a hourly basis, instead of on a monthly basis like you pay for your cable service at home or your electricity service or water rate. For cloud services, you generally pay, you are charged on a hourly basis. So you can start a server for 24 hours, run it for 24 hours, and you will get charged for the 24 hours only. If you shut it down for the next 24 hours, you will not get charged. You are charged only for the time that's used. Now, what are the different service models? You have software as a service, which is one of the models, and it's the top layer. It's at the top layer. You have the infrastructure under, you have the platform. The software as a service is at the top, and a lot of companies are providing these services today, like Microsoft Web Apps, providing software as a service, Google Gmail or Google App Engines. These are simple examples of public software as a service services that are available, and they have been available for a while. So instead of you downloading software and installing on your local computer, you will pay for the software and use it online. It's no need to download, no need to install anything. Everything is done via the web browser. Platform as a service. This is a capability provided to the consumer as they deployed cloud infrastructure. So let's say, for example, I need a PHP, I need a platform to develop my PHP application. I can go up and get a cloud service provider's URL, log on to the internet, and on their website I will be able to choose a server that already have PHP installed, or I will be able to choose a server that already have ASP or Tomcat installed, and I can use that as my platform to develop my web apps or to develop my applications. So the platform is, I was saying, in the middle. You have the infrastructure down, you have the platform in the middle, and you have the software as a service on top of it. So when you buy the platform as a service, you can install your own software on top of the platform, and you can also provide your own software as a services using this cloud platform. You don't have access to the physical infrastructure that's underneath. You only have access to the software platform that is on top of the physical infrastructure. So in other words, the platform, sometimes you can refer to it as the operating system. So you're buying a server running Windows Server, or you are running a server running Linux or Unix. You are buying a server running Mac OS X. That's your platform. You don't have access to the physical server hardware underneath. You only have access to the operating system level software. Then the infrastructure, that's the bottom layer. That's where you get to buy physical infrastructure. And buying this physical infrastructure means you are buying physical hardware, or it could be virtual hardware. You may not have direct access to touch and play with the hardware, but you can choose what software to run on this hardware yourself. So it's right at the bottom of the layer. Deployment models. How are cloud services deployed today? There are generally 4 deployment models. You have private cloud and community cloud. So in the private cloud, this is a deployment model wherein a company will decide to set up their own cloud services just for their own use. And this cloud service that they will set up, or this data center that they will set up to provide cloud services within the company, the data center could be located in-house in their back office, or it could be co-located in another data center somewhere else, and they will need to access that cloud serve this private cloud via the internet as well. So it's either in-house or it's co-located outside of the company, but it's private and it's used within the company alone. Public cannot use it, and the public may not even be able to see it directly. And you have the community cloud, which is about the same like the private cloud, but it's usually a cloud managed by people or set up for people with common interests. So let's say, for example, stock exchanges. Various stock exchanges can come together and set up a cloud, a community cloud service, just to provide them with their services that they need. So you have 3, 4, 5 companies coming together, setting up these cloud services and using them as one single community. Nobody outside the community can use it or access it. This again could be in-house, or it could be outsourced in another data center outside of your office. Or all these different companies that are part of the community could be co-located in the same building or in the same geographic area, and the data center is just probably below the building where they all have immediate access to it. You have the public cloud. This is the one we know about the most, like what Amazon provides on Microsoft Azure or Rackspace. So this is a cloud service that's available out to the public. You just go to the URL and you can buy platform as a service, software as a service, or infrastructure as a service, and use it as and when you want, just like you will buy electricity or buy water at home. So it's pretty much the commodity part of it. This is public, that's public cloud. The hybrid cloud it's the combination of private, community, and public. When you put everything together, you have a hybrid cloud. So a couple of these big companies like Amazon and Microsoft Azure, they have something like a hybrid cloud, because they do provide private clouds for some people, for some big companies. They do also serve as community cloud providers for a community of people that have common interests. For example, the Acquia Cloud. It's a typical, Acquia Cloud is a community cloud, you consider it, because it's built around Drupal, but it's based on the Amazon cloud. You can buy the services from Acquia, but it's based on Amazon, which is a public cloud. So it's kind of Amazon is I would call them an hybrid cloud provider at the same time, and they are also a public cloud provider. So they are in all the areas. So now let's talk about web architecture a little bit. We'll talk about web browsers, load balancers, cache servers, CDN, web servers, and application server, database servers, tiers, and the different layers. So we talk about typical tiered architectures. We typically have these three. There's 2-tier web architecture, 3-tier, and 4-tier. What each one of them are. Okay, so let's say the 2-tier architecture. In the 2-tier architecture, it's pretty much a client-server architecture. You have the client computer on one side and you have the server on the other side. Now, the clients communicate directly to the server via the internet or via some other local area network means. The web browser tier and the web server tier, these are the only 2 tiers here we have. It's 2. So you have the web browser, which is the client tier, same as the client tier, and the web server tier, which is the same as the application tier. Okay, and these 2-tier architecture is usually used by small companies, mostly for small traffic websites. Security is usually not a big concern for them, and you can have a single virtual dedicated server or a dedicated server that's running Apache and Microsoft IIS, running MySQL or Microsoft SQL, running Drupal using PHP or SharePoint using ASP.NET, all on one single server that serves as your application tier. And you have the client on the other side. This is a typical diagram. I don't know if this doesn't look too clear. You don't see the writing very much. But this is a typical tier of a 2-tier diagram. See right here, you have the server on this side, and you have the client on the other side. You have about 3 clients there. You can have as many clients as possible. The client side usually have a lot of devices, but in terms of hardware on the server side or the application tier, you only have one server, one physical server. This physical server will have a couple of software servers inside running applications. So that's why it's called 2-tier. You have one tier right here, one physical server machine, and over there you have several different client machines, but all of them together make up the client tier. You have the 3-tier architecture, which is no different, it doesn't have too much difference between the 2 and the 3-tier architecture. It's still a client server, but it has another server in the middle. So instead of one physical server on the application tier, you have 2 servers, and you can divide these 2 servers into 2 different tiers. So you have a web application tier, or you have an application tier and you have a data tier. The data tier will be the tier that will take care of all your database, and the application server will be the one running your MySQL, your Apache, your Microsoft IIS, and your Drupal or PHP. Okay? So this is usually used by medium-sized companies, and security is a little concern here. Security concern is a little high here, not as low as it is in the previous one, 2-tier. So they want to separate the database, the data layer, from the application layer. So once that separation is done, you have 3-tier. And a typical architectural diagram for that is this. You have 2 physical servers on this side. One of them is the database tier, the database server, the data server, and the other one is the web server. So on the web server side or the application server, that physical machine, you may be running other applications inside of this one, and here it's only data, only your databases. And the client side still stays the same. Now you have the 4-tier, which is used again by, this is very large companies now. One more separation, and it doesn't really exist that much. Most people don't consider it that we have anything more than 3 tiers typically, but I had to mention this 4th tier because it's being used a lot now, and people are talking about it a lot more, so why not mention it? So this tier typically includes the web browser tier again, which is the client tier on that side. You have the web server tier, so the web server by itself will be one layer, one physical machine only, running Apache or IIS, that's all it does. You have the application tier. This application tier will be another physical machine running Drupal or running Java or running any specific application that you have or that you want to run. And the database tier will be just for data. So you will have 3 physical servers, and the client side machines make it 4-tier. So you have 3 typical servers, and the client side make it the 4. So if you look at the diagram here, you still have about 3 physical servers, and on that other side you have the clients. They could be as many as possible, but what we want to concentrate on more is here. So you have 3 tiers here, 3 layers. You have the data layer, the application layer, and the web server layer down there. So that web server and the application layer can usually be considered one layer. This is usually considered one layer. That's why most people say it's only 3 tiers. We don't have anything past 3. This is the only one that's usually standalone. But the web server and the application together makes up the application layer. Okay? And you have a lot of other derivatives and other different formats or other different formulas. You see on the web server side, They are, depending on your use and your type of application, you may have 3 physical machines all running a web server. You might have 3 physical machines all running your application, and you might have 3 physical machines all running your database. You can have as many as you can depending on your application and depending on your user base, scaling horizontally. And this is another type of 4-tier layer, but in this layer here, you still have, this is one block or one pool of servers. This is another block and another pool of servers. This is your load balancers, and these are your cache servers or CDN servers, and this is the internet right here. So from the internet it goes to the CDN or the cache servers. From the cache servers goes into your load balancer. These load balancers can decide to send your traffic to any one of these 2 pools. You have A pool and B pool, and A and B are typically the same. They have the same information, they are doing the same thing, except that the load balancers will choose. If there are 1,000 users here already and this have nothing, the load balancer may send the other 1,000 users here, and it will try to balance the load between the 2 pools of servers to make sure that everything works correctly. So with this type of separations, some people may call this NTI. You may have so many different tiers now, because this whole thing here is one tier still, and then this is another tier right here, and you can consider this another tier. And if you break this down into different tiers, that this is tier 1, tier 2, tier 3, so you have 3 tiers right here. Then you have this 4, then you have this 5. That's how the N tier comes in. But in actual fact, you only have 3 tiers right here. These load balancers and these cache servers all come into one of those 3 servers somehow. And this is similar to the previous one, except that this time, instead of the cache servers being in front of the load balancers are in front of the cache servers. Some companies have this type of architecture. So it all depends on what you do and how you do it, and which one works best for you. So let's talk about the layers or the load balancers. What does load balancers do? Load balancers are usually computer or networking. It's a load balancing is a computing or networking method that's used to distribute workloads across multiple computing resources. So like in the diagram I showed you before, you have these computing resources here, region A and region B. The load balancer is right there. The load balancer distributes the load to these different resources. Okay, so what type of resources does the load balancer distribute to? It distributes to a computer cluster, to network links, to central processing units, to disk units. It optimizes resource use, it maximizes throughput, it minimizes response time, and it avoids overloads of any one resource. Now, cache servers, we have a couple of examples here. We have Vanish, we have Squid, we have Memcache, we have Reddish, and we have content delivery networks like the Amazon CloudFront Content Delivery Network and the Akamai network, content delivery network. These are all strategies that companies use to implement high traffic websites. And these are considered by some people as another tier by itself, just like I showed you in the diagram. So each one of these can fall in, you can use any one of them at this caching level. And in some cases, those caches are actually built into these servers as well. Instead of being hardware machines by themselves, they are built in here. Sometimes, depending on the application. I run a server, for example, right now wherein I have a cache server built into, it's a small site, it's just a single machine. Everything is just 2-tier. Everything is in that single machine. Memcache, the web application, Apache, PHP, MySQL, everything is on that single machine. But as it starts to grow, I may need to split them up differently like this. You wouldn't expect Amazon or Google to do that. They will do something like this at a much, much bigger scale, making everything separate, each machine being by itself, right? So content delivery networks, and these are interconnected and geographically located servers that provide continuous web content to users based on their proximity. I think I mentioned this earlier, but I'll come back to this at some point with a diagram and explain it a little bit more. But content delivery networks are pretty good for companies, especially that are streaming audio and video. And if you have a lot of photos also on your site, this is perfect, because what it does is it caches your information at locations that are closer to the clients, so that when the clients try to access these resources, they will get a faster response time as opposed to going through all the network hubs to get to the actual content. Okay, so this is used by a lot of companies now. This is a typical example. I didn't think I had this diagram here that shows you how CDN works, right? So you have, this is you right here, one. This is the origin server. The origin server is talking about your server. This is where you have all your information. From your origin server, the information comes in here, and in here you have, these are Amazon's edge servers. These are the servers that Amazon have distributed globally, So from your origin server, it comes into the edge server. And from the edge server, when a customer requests the information, it can go in here to get it from the origin server, or it can come right here and get it from one of these distributed servers. So if the information is here already, it usually just picks it up right here. If it is not here, it will go here and pick it up. And as soon as it picks it up here, this guy will know that they have to bring it down here. And when they bring it down here, the next time this guy requests, they will get it from down here. And these are just links now to different nodes. And this could be, again, different clients like you, different clients here, connecting to just pick the information from here. So instead of going up here for the information, they pick the information from down here from the top. So one origin server, two the Amazon distributed servers, and then three your clients get the information. Okay, so now let's talk a little bit more about the tiers. We're going to talk about the client tier. So we're left with three main tiers. We'll talk about the client tier now. So for web applications, the client tier consists of the user workstations. Okay, for web applications, the client tier is the user workstation. Your laptop, my desktop, your desktop, my tablet, your tablet, my smartphone, your smartphone. This is the client tier, because we access the information using our devices through the browser, using the internet. So on the hardware side, we are talking about our devices. Okay, now computers in the client side use DNS and use LDAP and UDDI to find the correct information that they want. Okay, now on the software side, for the same client tier, our computers will have an operating system. Our smartphone, our tablet, our desktop, laptops, they have an operating system, Windows, Mac, or Linux. And we also have browsers. So these browsers will interact with our application on the web to access the information. So on the client's tier, hardware is our machines, software is the operating system and the browsers we run on our computers and on our phones, on our tablets. Security, well, the client tier quite often exists in a separate security context from that of the other tiers, because this is security on your individual machines. We are not talking about security on our side, on the provider side. So you will have to maintain your own security on your device, and depending on how you have your security on your device, several different things might happen. Okay? So now the application tier, what's the hardware? As I mentioned before, you could have 1 hardware, 2 hardware, 3, 4, as many as you can depending on your demands. So the computers in the application tier are servers, the configuration of which must balance between the conflicting resource requirements of an application server and a web server. Okay? So because application tier servers are web servers, this tier often must contain multiple servers configured as a server farm to meet scalable and fault-tolerant operational requirements. That's why you saw the 3 servers on the diagram before. In the 4 servers, you have all these different configurations, right? Now, on the software side, the servers in the application tier have both web server and application server software installed. The application server software provides the execution context for the application logic. And for an overview of this, you can think about Microsoft Server 2003 as a server application. You can think of Apache. If you install Microsoft Server 2003, it does a lot more than just web serving. Okay? Security. The servers in this tier usually reside within the same security context. So the security context is all within the server side. So therefore, they can interact with each other using a common security infrastructure. So you have multiple servers. Once you have multiple servers, these servers are usually on the same network. And this network security is usually the same for all the different servers, so you don't have too much problems with security within. But when you do the separation, sometimes security concerns can be the reason why you do the separation, because you don't want one server to access the other server without certain permissions and all that. And you have the data tier. The data tier hardware is the computers in the data tier are sized and configured as enterprise servers. The servers are optimized for input and output throughput and hard disk utilization. If the scalability and fault tolerance operational requirement dictate that you have multiple servers in this tier, they are almost always configured as a server cluster. So this is your database. Remember, you have a master database, you have a slave database. So you have all these different databases running your database application in a server cluster. That's what the data tier server is talking about. And then you have the software in the data tier area. You talk about Microsoft SQL Server 2000. You can talk about Oracle or Microsoft SQL Server 2008. You can talk about what again? MySQL. You can talk about NoSQL database servers like MongoDB and all that. Now, security, because of the need to protect corporate data assets, the data tier often has the most stringent security requirement of all tiers. So accessing, that's one of the reasons why most companies will separate the data tier from the application tier, because the application have the logic. It doesn't really have any real data. It just have the logic to manipulate data. And the data tier, that's where the actual content is. That's where the actual information is. So some amount of restriction is usually needed to ensure that the wrong person doesn't get access to information that they are not supposed to get access to. Okay, and I think we'll end this session here. I don't want to make the videos too long this time. So this is all we have for the web computing session, and we'll come back next and continue with our next session, which will be web application.